Welcome back to P3. Today we're looking at Unit 3.3 using Secx, Cosec and Cotx. Now with these you need to be able to simplify expressions, prove identities and solve equations involving all three. It should also be worth noting that with Secx and Cosec, because of the type of graph they are, if you remember the graphs, they don't have any solutions between -1 and +1. Just remember, for example, the Cosec graph looks like this very quickly. So between our 1 and our -1, there's no solutions. Okay, so it's just one thing just to be aware of when we do these. Let's get started with some examples. Nice straightforward one here. Write the value of cot x when 8 sin x equals 3 cos x. So remember that cot x is 1 over tan, but it can also be written as cos over sine. And this second one is the one that is important here. So knowing I need to get it as cos over sine, I'm going to divide through by sine. Normally I do this in one go, but let's take it in 2 steps. And then divide through by the 3. And that's going to be equal to cot x. And that's where I stop here. Now, if obviously I needed to solve it, then I would have to change it into tan to be able to solve. But we'll look at those type in a moment. So here's one where I need to solve this equation. So my first step is to change my cot, and it makes sense not to turn it into tan, but to turn it into cos theta over sine theta. And that's because I've already got this in terms of cos. Now if I multiply through by sine theta, I get 5 sine theta cos theta equals 2 cos theta. Now a lot of people in this situation will be very tempted to divide through by cos theta, but doing so would mean that you'd lose one of your solutions. So in a situation like this, you always need to get things to one side and factorize. So it doesn't matter which way around I do this, but I'm going to take the 2 cos theta onto my left, and then I'm going to factorize out cos theta. So 5 sine theta minus 2 inside my brackets. Now that I can say that cos theta equals 0, or 5 sine theta minus 2 equals 0. So sine theta equals 2/5. Let's just move this over here. Okay, now I want to find out my values of theta, and then of course I need to work them out between 0 and 360 degrees. Now for the first one, I know that cos theta equaling 0 happens at 90 degrees and 270 degrees, so that's nice and easy. My second one, now I used calculator for this one, and I get 23.6 degrees. Now I'm going to use the cast rule just to find my additional ones for here. So 23.6 degrees, and I still keep the full value in the calculator when I'm doing this, but if I'm rounded to 3 significant figures or 1 decimal place, it doesn't really matter, but it is better to keep your full answer in your calculator. So we want in here this one, first one, and the next one where sine is positive is here, as this clearly means that sine is positive. So the second value is going to be 180 minus my 23.6, and that's going to give me 156.4. Okay, so my set of values is 23.6 degrees, 90 degrees, 156 degrees, and 270 degrees, and these are all the three significant figures. Okay, you just choose what's relevant or what you think is the best or most reasonable rounding if you are not told. If anyone's not sure how to use the cost diagram, like I'm using it, and they're unsure, drop a comment either below the video or send me an email, and I'm happy to make a video just based on that. Now, I want to prove that like this. You can see I've got my equivalent sign here. Okay, it's an identity, and I need to pick one side to start. Again, this type of question where people go wrong is that they keep this all together almost like an equals, and they start bringing things to this side or from this side to this side, and that's where they really mess up. You need to pick to one side, start, and then hopefully end up with the other side. Now, I'd say 9 times out of 10 the questions seem to be set up to favour starting from the left hand side, but there are a few where sometimes it's easier to start from the right hand side, and there's even a couple where sometimes I might start on the left and on the right and see where I end up joining in the middle and finishing from there. If we get one of those, I will show you. So starting from the left hand side, I'm going to expand this bracket. So 1 times 1 is 1. Sorry. And then I've got 1 times sec x minus cos x times 1 is minus cos x, and then minus cos x sec x. So the first thing I'm going to deal with is my cos x times my 1 over cos x, that's sec x there. These will cancel, leave me with negative 1, and obviously 1 take away 1, 1 take away negative 1, or 1 take away 1 I should say, will just leave me with sec x minus cos x. Now sec x is obviously 1 over cos x. Sorry, just making a bit of room there. And now what I need to do is I need to turn these over a single fraction. So again, I'll do this in one go. If anyone's have any doubts, just please drop a comment below and I will reply to you. So looking on the top now, I need to get this in terms of sine and tan, and I've got 1 minus cos squared. So I'm just going to go over here in black as a reminder. Sine squared x plus cos squared x equals 1. So sine squared x is equal to 1 minus cos squared x. So that means that I can replace the top of this fraction with sine squared x, and that's over cos x. So I'm just going to go up to here, give myself a bit more room. So sine x over cos x times sine x. So I'm splitting up my sine squared here, and sine over cos is tan, so let's write it this way around. And then finally that clearly equals the right hand side, and I am done. Okay, so look at number 1 here. So let's start with the left hand side. So cos theta plus sine theta tan theta. So we get cos theta plus sine theta, and then tan is sine theta over cos theta. So let's make this one cos squared theta over cos theta, and then this one is obviously sine squared theta over cos theta. Now you can see that they're the same bottom number value, the cos theta, so I can put them together. Cos squared theta plus sine squared theta over cos theta. So that is equal to 1 over cos theta, which equals sec theta, therefore equals the right hand side. Number 2. Let's start with the left hand side. So we get cosec theta minus sine theta. So obviously cos theta, cot theta is together, so it looks like we're going to put these two together as a single fraction. So we get 1 over sine theta minus sine squared theta over sine theta. So that's 1 minus sine squared theta over sine theta. 1 minus sine squared theta is cos squared theta. So cos squared theta over sine theta. So that's cos theta times cos theta over sine theta. And cos theta over sine theta is cot. So cos theta cot theta. And there is the right hand side. Okay, now you might be feeling a little bit overwhelmed with some of these, but the more of these are practiced, the easier it is to spot the kind of path that you need to take. Okay, so it is for this kind of stuff. These prove that with the trig identities as well, coming up in the next video. It is practice with these. And the third one, question 3. Again, I'm going to start with the left hand side, and it looks like I really need to put these two as a single fraction. So I'm going to do that in one go, save a little bit of time. Okay, so that will be cos squared x on the top there, and 1 minus sine x squared on the other one. Okay, because obviously then that would still cancel out to give you the same original fractions. Now at this point we want to expand the top. So cos squared x plus 1 minus 2 sine x plus sine squared x. And let's expand the bottom. That gives me cos x minus sine x cos x. Oh, that might have been an error on the bottom there. We'll see how it goes. So looking at this, cos squared x and sine squared x is 1. Oh yeah, that bottom was definitely an error. Let's put it back to the original. I can see it. Okay, so on the top we've got our, I'll do this in black here, cos squared and sine squared. That's going to give me 1 plus my other one, so I've got 2 minus 2 sine x over 1 minus sine x cos x, and factorising 2 out to the top gives me a 1 minus sine x over 1 minus sine x Cosec. And there you can see why I said that I jumped the gun a little bit on the bottom one earlier. Those will cancel. And that will leave me with 2 over cos x, which is 2 sec x, which is the right hand side. Okay. Now we're on to the solving ones. So first one, sec theta, I'm going to divide by the 2 over root 3, although that might have been again a step I shouldn't have taken just yet. So cos theta is 2 over root 3, 1 over cos theta. So cos theta is root 3 over 2. So theta equals, so that gives me 30 degrees. Just thinking of the cast rule here. 30 degrees positive cos, so we're looking here. So it's going to be 360 minus 30, so 330 is my second angle there. And number 5, let's jump in. So it's a cot theta minus 2 over 5. So it's 1 over tan theta minus 2 over 5. Tan theta equals negative 5 over 2. So find theta first. Now personally I tend to just find the positive version initially. So I would do inverse tan of 5 over 2, because that will then give me this angle here. Okay, as a positive angle. Then tan is negative, so I want these two sections. So I've got 180 minus my 68.2 and 360 minus 68.2. So 111.8 and 291.8. Okay, I suppose you could also do 112 and 292 if you want to do 3 significant figures, as is often the case with angles. That or 1 decimal place. Don't do any more than that. Number 6. So 3 sec squared theta. I'm going to take the 4 to the other side. Sec squared theta equals 4 thirds. 1 over cos squared theta then is that 4 thirds. So cos squared theta is 3 over 4. Then I want to square root. So cos theta is plus or minus, very important there, root 3 over 2. Positive root 3 over 2 is going to give me 30 degrees. Okay, 30 degrees. Now I want positive and negative, so I'm actually want the angle in each quadrant here. So we've got 30, 180 minus 30, we've got 180 plus 30, and then finally 360 minus 30, and that gives me the angles in all 4 quadrants there. Okay, number 7, similar to one I did earlier. So I change the cot into cos theta over sine theta, multiply by the sine theta, take everything to one side, and factorize. So cos theta equals 0 or 5, sine theta minus 3 equals 0. So sine theta equals 3 over 5. So So let's get our values of theta. So from the cos side is at 90 degrees and 270, should know those. And then at the sine side is 36.9 degrees, and using my cast rule to help me find any additional angles. So 36.9 is in there. Sine is positive, so I also want this one. So 180 minus 36.9 is 143.1. So here are my angles: 36.9, 90, 270 and 143.1, and of course they're all degrees. And finally, of this section, number 8, so let's jump straight in. 2 sine theta equals, and this is 1 over sine theta, multiply by that, so 2 sine squared theta equals 1, sine squared theta equals a half, sine theta equals plus or minus 1 over root 2. This is a really common angle, so we should know that this equals 45 degrees. Then using my cast rule, or method I suppose more than a rule, but we've got 45 degrees in there, and we want positive and negative, so we want all 4 quadrants. So 180 minus 45, 180 plus 45, and 360 minus 45. And there we have it, 4 angles. Okay, number 9. So let's jump straight in. 1 over cos theta equals negative 1. So we're going to have negative 1 equals that cos theta there. Now at this point you can work it out in degrees first and then switch to radians if that's what you're more comfortable with. Okay, nothing wrong with that. You've got to stick with what works for you the best. I mean, in quite a few of these I do prefer to work in degrees, but sometimes I'll work in radians as well. Doesn't really matter so much, but I do prefer degrees in general. So this one, minus 1, it's at 180 degrees or pi radians, and it's the only possible value between 0 and 2 pi. And number 10, I did notice on the last little bit I had a 2 on the bottom instead of a 3, don't know why. Right, let's start. So 1 over, actually before we even start, let's just jump straight in. So if you've got an angle that isn't just a single angle, think about swapping it straight out for a new letter. So let x equal theta over 2. And also, if you do that, then you do need to adjust your range. So to do that, start with the original range. In this case then we need theta over 2. So theta divided by 2 means I divide my range by 2. And then that theta over 2 is just x. So this is now my new range, and I'm looking at cosec x equals 2 root 3 over 3. So 1 over sine x is 2 root 3 over 3. So sine x is 3 over 2 root 3. And in radians that gives me pi by 3, or 60 degrees. Now let's go to my cast rule, or method I should say. I keep saying rule, it's not really a rule. So pi by 3 will go there, 0, round to 180, back round to 360, and so on. Sine's positive, so that's there and here. And sorry, I've written 180 there. Let's keep it all in radians. 2 pi. So pi minus a third pi is 2/3 pi. So my second angle is 2/3 pi. But now these are my angles for x. So I'm going to come up onto the right. I'll start in black now just so that it stands out. So these are my two answers at the moment based on my x. And now I need to replace that with pi by 2. And then that means that to get theta, sorry, not pi by 2, theta by 2, at theta I need to multiply by 2. So that's 2 pi by 3 and 4 pi by 3. Now, it's really important that you do approach this kind of method when your angle is not a single angle, okay? Because what I see all the time in my years of teaching is that the students who don't do it this way tend to get just the first angle right and the subsequent angles wrong. Okay, it's very important that you get in the right place first, so this is the easiest way to do that. Number 11a. So first we need to prove this. So let's start with the left hand side. Cosec theta, it's awkward, isn't it? Let's just jump straight into 1 over sine theta minus cos theta over sine theta for my cot, and this is all over 1 minus cos theta. So on the top then I've got 1 minus cos theta over sine theta, and that is over 1 minus cos theta. Getting quite confusing there. Now I've essentially got a fraction. If I put a 1 there divided by a fraction, so I can turn that into 1 minus cos theta over sine theta multiplied by 1 over 1 minus cos theta. Okay, so remember, divided by a fraction is the same as multiplying by its inverse. So just pop those in brackets so you can see those will cancel out, leaving me 1 over sine theta, which is cosec theta. And that is equal to the right hand side. Part B is very straightforward. So you can see that this and this are the same thing. So that means that cosec, so we can go from our cosec theta minus cot theta over 1 minus cos theta equals 2, and we can replace that just with cosec theta equals 2. Dead easy. 1 over sine theta equals 2. So sine theta equals 1 over 2. Okay, so that's 30 degrees, but we're in radians, so we're looking at pi by 6. So my theta here is going to be pi by 6. Now I need to just check out my range. So again, using the cast method, we got pi by 6, and we've got to go from 0 to pi, positive direction, and then we need to go from 0 to negative pi in the negative direction. Now sine is positive, so we're only looking at these two, so these are going to be our only answers. So pi minus pi by 6 is 5 pi by 6, and those are my two solutions. Long one tonight. Right, let's have a little look at this. So we got 1 plus 1 over tan x over 1 plus tan x equals 5. Okay, so I'm doing that so things in terms of tan. So 1 plus 1 over tan x, I'm going to multiply by the bottom of my fraction here, like so. So 1 plus 1 over tan x is 5 plus 5 tan x. Now, let me just, I'll simplify actually afterwards. Let's multiply through by tan x. So that's tan x plus 1 equals 5 tan x plus 5 tan squared x. Now let's get everything onto the right hand side. So 5 tan squared x plus 4 tan x minus 1. And then I can factorize this. So we got 5 tan x and tan x. Obviously got 1 and 1 plus and minus. So that'll give me 5 tan squared x plus 5 tan x minus 1 tan x, and then minus 1. Okay, so 5 tan x minus 1 equals 0, or tan x plus 1 equals 0. So we've got tan x equals 1/5, tan x equals -1. So the angles that will give me, so this one's easy. It's actually probably going to be that -45. I personally just use the positive value for this one. And then in the calculator, I get 11.3 for this one. So I'm going to do these two separately with two small cost diagrams here. So first one, tan is positive, so I want here and here. So you can see, and I'll actually pop the answers in black. So we've got x equals obviously my 11.3, and my second angle there is 180 plus it, so 191.3. And in the second one, this size of angle is 45, but I want tan negative, so these two sections are my important ones. So we're looking at 180 minus 45, so x is 135, and 360 minus 45, so 315. So my values are 11.3, 135, 191.3 and 315 degrees. Now, hopefully you followed this one, and it looks all right algebraically. It looks all right, but unfortunately these angles, these two, they're not solutions to this problem. Okay, and it comes very simply when tan x equals -1. If I look up into my equation here, if tan x is -1, then I'd have 1 plus -1. Bottom of this fraction would be 0, and that's obviously can't happen. So tan x cannot equal -1. Okay, so at this point, if you notice that, you could then get rid of that for that reason. Yeah, tan x cannot equal -1 because it makes the bottom of my fraction 0. Okay, and that would give me my two answers, which were x equals 11.3 and 191.3. Okay, I'm going to do this again with an alternative method, but instead of using tan, using sine and cos. So this time I'm going to use sine and cos. So cos x over sine x and sine x over cos x equaling to 5. So look at the top of my fraction, I've got sine plus sine x plus cos x over sine x. And then the bottom fraction would be cos x plus sine x over cos x. So as we said before, fraction divided by fraction, same as multiplying them. So sine x plus cos x over sine x multiplied by, so the inverse of cos x over my cos x plus sine x. And you should be able to see that these two are the same. And of course this equals to 5. Now we're left with cos x over sin x equals 5, or cot x equals 5. Cot is 1 over tan, so I could just jump straight in there with tan x would be equal to 1/5. So x equals 11.3 degrees. Okay, then go into my cast method. It's positive tan, so here and here. So 113 degrees, and 180 plus that will give me 191.3 degrees. And this way now I've got my two correct solutions without any potential errors creeping in there, and it was also, I would say, a little bit quicker, I thought myself. Sorry it's a long video, hopefully you have found it useful. Stay tuned, the next video will be trigonometric identities. So built from sine squared plus cos squared equals 1, but interversions in terms of tan, sec, cot and cosec squared terms. Okay, please hit a like and subscribe, and hopefully you'll come back for some more videos.